Okay, here's 2.3b, biconditionals and definitions. Objectives. Students will be able to write biconditionals and recognize good definitions by analyzing advertisements. Well, we already did that kind of yesterday or last class, but basically what we're going to do, we're going to just go over what biconditionals and good definitions are in today's notes. So a biconditional, this is when a conditional and its converse are both true. When they're both true, they can be combined into one statement, and this is called a biconditional statement. And there's some language that we use. Notice this isn't a typo, this IFF. This is shorthand. This is shorthand for if and only if, and we're going to use this a lot when we use biconditionals. So we're going to just use if and only if. All right, let's do some examples here. It says determine if the following statement can be written as a biconditional. Remember, they both have to be true. Both the original and its converse have to be true. So let's do some evaluating here. Well, if three points are collinear, then they lie on the same line. Well, is that true? If 3 points are collinear, then they lie on the same line. Well, yeah, that's what collinear means, right? Collinear means on the same line. So this works. Truth value is, yeah, it is true. So let's write the converse then. The converse would say if 3 points lie on the same line, then they are collinear. Then they are, I'm going to try and fit collinear in here. Collinear. 3 points on the same line, then they are collinear. Okay, so we wrote the converse. Well, is that true? Let's see. If 3 points lie on the same line, then they are collinear. Yeah, if 3 points are on the same line, then we would call them collinear. So yeah, that's true as well. So that means we can write this as a biconditional. So here we go. We no longer use, when we go to write the biconditional, we no longer use the if part and the then part, and we're going to replace it with if and only if in the middle. Here's how it goes. 3 points are collinear. If and only if, but remember we're just going to write IFF, if and only if they lie on the same line. All right, there we go. I want you guys to try this as well, but remember you can only write the biconditional if both the original, so both the original statement, which I have up here, and its converse are true. So I want you to, here's the original statement for this next example, and you're going to find the truth value and the converse, and you're going to determine if both of those are true. If they're both true, then write it as a biconditional. If they're not, then you're just going to say, can't be written as a biconditional. So I would have you guys pause the video now and go ahead and fill that in. Okay, well, here's what you should have got. You should have said, if you live in Vacaville, then you live in Northern California. That is true. And the converse would be if you live in NorCal, then you live in Vacaville. I know my handwriting is still hard to read on this thing, but it'll get better, I promise. And that's obviously not true, right? So we could say not true. And why? Well, we could live in Fairfield. We could live in Sacramento. We could live in San Francisco. Those are all still Northern California, and they're definitely not Vacaville. So we can't even write this as a biconditional because it's not true both ways. All right, let's go on. Okay, here we go. Let me zoom in here. Now we're going to go from a biconditional to writing it as two different statements. So here I have, write the biconditional as two conditional statements. Two angles are congruent if and only if they have the same measure. Well, I'm going to break this into two conditional statements. So I'm going to say, hey, if two angles are congruent, then they have the same measure. All right. And then the second conditional is just the converse of whatever the first one you wrote is. So we would say if two angles have the same measure, then they are congruent. There we go. So that's all you're going to do is you're going to take this biconditional statement and break it into two different statements. So we're going to get rid of that if and only if, and now add the if and the then back in, and then write the converse using if and then. So I want you guys to go ahead and try that with practice number 3, and go ahead and pause the video. Okay, well here's what you should have had. You should have said, hey, if x equals 5, then x plus 5 equals 10, and its converse would be if x plus 5 equals 10, then x equals 5. There we go. So let's move on now. Now we're going to talk about good definitions. And I know this says use, but I'm going to just kind of change the wording here to good definitions are. Okay, so instead of use here, let's cross that off and let's try good definitions are. Because, let's go into this. Let me change my color here real quick. Okay, good definitions are, very first thing, they are clear. Good definitions are clear, okay? This means no confusing words, or no words that are undefined. So you ever looked up something in a dictionary and it gives you these definitions and they're really hard to understand, like you don't even understand the definition because you don't understand the words in the definition? Well, that would mean it's kind of a bad definition, right? So we want to use words that are easily understood. So no words that are undefined or not already understood. So that's what I mean by clear. And good definitions are also precise. They are precise. And that means there's no words like, let me write like and then put no kind of or sort of or large, right? Because these words are too vague. So we need to use words that are less vague and more specific, more precise. So we need to use words that are precise in a good definition. And lastly, and this is the part that relates to biconditionals, good definitions are reversible. Just like these biconditionals, right? I could reverse these statements and they were still true. So that means that they can be written as a biconditional. Can be written as a biconditional. So I know my handwriting is hard to read here, but that means that both the converse and the conditional are true. Okay. And we call that the CPR check, because just clear, precise, reversible, right? So that is the CPR check. So when I ask you to check if these are good definitions, you're going to do the CPR check. All right. So let's do some checks here. So determine if the following statements are good definitions. Explain. Well, first example here says a right angle is an angle whose measure is 90. Is that clear? Well, we know what a right angle is, and we know what the word measure means, and we know what 90 means. It's referring to 90 degrees. So yeah, that is very clear. Is it precise? Well, let's see. A right angle is an angle whose measure is 90. Yeah, 90, that's very precise language. There's no language in here like kind of, or like it's kind of 90, or it's usually 90, or it's sometimes 90. No, it's very, very precise. So yeah, it qualifies there. A right angle is an angle whose measure is 90. Is that reversible? Well, could we say an angle whose measure is 90, an angle whose measure is 90 is a right angle? Could we say it the other way around? Yeah, we could. That's still true. So it works. Therefore, this is a good definition. Good. Why don't you guys try practice number 4, see if it passes the CPR test. What do you guys think? Go ahead and pause the video and do it on your own. Okay, well, a line segment is any part of a line with two endpoints. That any part seems like it might not be very precise, but it's actually pretty good. This is a pretty good definition. A line segment is any part of a line with two endpoints. It's very clear. We should know what line segment is, and we should know what endpoints mean. Precise, yeah, it is part of, but it's just because a line segment can be really long or really short, so it doesn't really matter how long it is. So it's just any part of a line with two endpoints. So it's precise enough for what we need to define. And is it reversible? Could I say that any part of a line segment, or yeah, I'm sorry, any part of a line with two endpoints is in fact a line segment? Could I say that? Yeah, I could. So it is reversible. So that is also a good definition. I wanted to give you guys an example of a bad definition, though. So I'm going to write that down here below summary, and we will probably do this in the warm-ups if you're in class today. But it is a carrot is a vegetable. And let's put this thing through the CPR check. Ready? So is it clear? A carrot is a vegetable. Well, that's clear. Is it precise? A carrot is a vegetable. Yeah, there's no like language in there that's vague. But is it reversible? Could I say a vegetable is a carrot? No, that would not work, right? A vegetable is not necessarily a carrot. A vegetable could be other things, right? It could be like, I don't know, broccoli or spinach or some of those other things your mom makes you eat that you don't really like, right? It could be any one of those things. So that would be an example where we would have C check, P check, but R reversible would not work. So this would not be a good definition. So I thought I would just show that to you as well. All right. That's it for 2.3b.